Bismillahirrahmanirrahim. Assalamu alaikum, friends. Today, the topic for our lecture is algorithms. The points we will discuss in this lecture are firstly, the introduction, then, what is an algorithm, properties of an algorithm, analysis, kinds of analysis, advantages of algorithm, characteristics of a good algorithm, how to write an algorithm, some examples and method. In this lecture we will study that what are computer algorithms. Firstly, the introduction of the topic. The word algorithm comes from the name of a Persian mathematician, Abu Jafar Muhammad ibn Musa al-Khwarizmi. In computer science, this word refers to a special method usable by a computer for solution of a problem. The statement of the problem specifies in general terms the desired input-output relationship. A finite set of steps that must be followed to solve any problem is called an algorithm. Algorithm is generally developed before the actual coding is done. It is written using English like language so that it can easily be understandable even by non-programmers. An algorithm is a written or verbal description of a logical sequence of actions applied to objects. We use algorithms every day. Recipes, instructions, and directions are all examples of algorithms that are not programs. Now let's address our first question. What is an algorithm? Algorithm is the sequence of steps to be performed in order to solve a problem by the computer. An algorithm is a set of instructions designed to perform a specific task. This can be a simple process such as multiplying two numbers or a complex operation. In computer programming, algorithms are often created as functions. An algorithm refers to a step by step list of instructions to solve an instance of a problem. Algorithms are finite processes that are solutions in themselves. An algorithm is a specific procedure for solving a well defined computational problem. An algorithm is simply a set of steps used to complete a specific task. So, here are some properties, analysis, and advantages of algorithms. Properties of algorithms. The given problem should be broken down into simple and meaningful steps. The steps should be numbered sequentially and the steps should be descriptive and written in simple plain English. Okay, analysis of algorithms. The theoretical study of computer program performance and resource usage. What's more important than performance? Modularity, correctness, maintainability, functionality, robustness, user friendliness, programmer time, simplicity, extensibility, reliability. Then why study algorithms and performance? Algorithms help us to understand scalability. Performance often draws the line between what is feasible and what is impossible. Algorithmic mathematics provide a language for talking between program behavior. But the lessons of program performance generalize to other computing resources. Speed is fun. So, here are some kinds of analysis. Worst case, usually Tn is equal to maximum time of algorithm on any input of size n. In average case, sometimes Tn is equal to expected time of algorithm over all inputs of size n. Need assumption of statistical distribution of inputs. And the best case, cheat with a slow algorithm that works fast on some input. The advantages are it reduces complexity by dividing the program into simple and meaningful parts. increases flexibility. Algorithms is written so that the code may be written in any language. Ease of understanding, no need to understand a particular programming language to understand an algorithm. Promotes effective communication between team members and it enables analysis of problem at hand. Acts as blueprint for coding. Assist in debugging. Becomes a part of software documentation for future reference during maintenance phase. Some characteristics of a good and correct algorithm. It has a set of inputs, steps are uniquely defined, has finite number of steps, produces desired output. Following are the steps to write an algorithm. How to write? There are many ways to write an algorithm. Some are very informal, some are quite formal and mathematical in nature, and some are quite graphical. The development of an algorithm, a plan, is a key step in solving a problem. Once we have an algorithm, we can translate it into computer program in some programming language. Our algorithm development process consists of 5 major steps. Step 1, obtain a description of the problem. Step 2, analyze the problem. Step 3, develop a high level algorithm. Step 4, refine the algorithm by adding more details. Step 5, review the algorithm. So, method number 1. Step 1. Obtain a description of the problem. This step is much more difficult than it appears. It's quite common for a problem description to suffer from one or more of the following types of defects. Number 1, the description relies on unstated assumptions. Number 2, the description is ambiguous. Number 3, the description is incomplete or the description has internal contradictions. Step 2, analyze the problem. The purpose of this step is to determine both the starting and the ending points for solving a problem. A good problem description makes it easier to perform this step. When determining the starting point, we should start by seeking answers of the following questions. What data are available? What is the data? What formulas pertain to the problem? What rules exist for working with the data? And what relationships exist among the data values? When determining the ending point, we need to describe the characteristics of a solution. In other words, how will we know when we are done? Asking the following questions often helps to determine the ending point. What new effects will we have? What items will have changed? What changes will have been made to those items? And what things will no longer exist? Step 3 is to develop a high level algorithm. An algorithm is a plan for solving a problem, but plan comes in several levels of details. It's usually better to start with a high level algorithm that includes the major part of a solution, but leaves the detail until later. We can use an everyday example to demonstrate a high level algorithm. For example, the problem is I need to send a birthday card to my brother, Mark. Analysis: I don't have a card. I prefer to buy a card rather than make one myself. Then a high level algorithm, which is to go to a store that sells greeting cards, then select a card, purchase a card, mail the card. Step 4, refine the algorithm by adding more details. A high level algorithm shows the major steps that need to be followed to solve a problem. Now we need to add details to these steps. But how much detail should we add? Unfortunately, the answer to this question depends upon the situation. We have to consider who or what is going to implement the algorithm and how much that person or thing already knows how to do. When our goal is to develop algorithms that will lead to computer programs, we need to consider the capabilities of the computer and provide enough detail so that someone else could use our algorithm to write a computer program that follows the steps in our algorithm. The last step, step 5, is review the algorithm. The final step is to review the algorithm. What are we looking for? First, we need to work through the algorithm step by step to determine whether or not it will solve the original problem. Once we are satisfied that algorithm does provide a solution to the problem, we start to look for other things. Other things include, does this algorithm solve a very specific problem or does it solve a more general problem? If it solves a very specific problem, should it be generalized? Method number 2. Step 1 is to determine the outcome of your code. What is the specific problem you want to solve or the task you want it to accomplish? Once you have a solid idea of what you are aiming to accomplish, you can determine the steps it will take to get there. Step 2 is to decide on a starting point. Finding your starting and ending points are crucial to listing the steps of the process. To determine a starting point, determine the answer to the following questions. What data or inputs are available? Where is the data located? What formulas are applicable to the issue at hand? What are the rules to working with the available data? And how do the data values relate to each other? Step 3 is find the ending point of the algorithm. As with the starting point, you can find the end point of your algorithm by focusing on these questions. What facts will we learn from the process? What changes from the start to end? What will be added or no longer exist? Step number 4, list the steps from start to finish. Start with the broad steps. To use a real world example, let's say your goal is to have lasagna for dinner. You have determined that the starting point is to find a recipe and that the end result is that you will have a lasagna fully cooked and ready to eat by 7 p.m. Your steps may look something like this. Search for a recipe online. Look for the ingredients you already have in the kitchen. Make a list of ingredients you will need for this from the store. Buy the missing ingredients. Return home. Then prepare the lasagna. Remove the lasagna from the oven. Step 5, the last step, is to determine how you will accomplish each step. Now that you have a step by step outline, it's time to think about how you might code each step. Which language will you use? Okay, what resources are available? What's the most efficient way to accomplish each step in that language? Step 6, review the algorithm. Ask yourself the following questions and address each as necessary. Does the algorithm solve the problem or accomplish the task? Does it have clearly defined inputs and outputs? Should the end goal be redefined to be more general or more specific? Can any of the steps be simplified? Is the algorithm guaranteed to end with the correct result? So, here are some examples. Algorithm to add two numbers entered by the user. Step 1 is start, then step 2 declare variables number 1, number 2, and then sum. Step 3 read values number 1 and number 2. Step 4 add number 1 and number 2 and assign the result to sum, a variable. Step 5 display sum, and step 6 is stop. The next example is to find the Fibonacci series till term less than or equal to 1000. Step 1 start, step 2 declare variables, first term, second term. Step 3 initialize variables. Step 4 display first term and second term. And then repeat the steps until second term is less than or equal to 1000. Display second term, and last step is to stop. Check whether a number is prime number or not. Okay. Factorial of a number entered by the user. These are the steps for writing the algorithm. How to write the algorithm for roots of a quadratic equation ax square plus bx plus c is equals to 0. So step 1 start, then declare variables, then step 3 calculate discriminant, step 4 if else statement, and step 5 stop. Find the largest number among three different numbers. Similarly, start, then declare variables a, b, and c. Step 3 to read variables. Step 4 is condition, if else statement. Step 5 is stop. Another algorithm that reads three number and print the value of the largest number. Here are some algos you should try by yourself. Write an algorithm that reads two values, determines the largest value, and print the largest value with an identifying message. Okay, friends, this is it for now. Thank you for watching this presentation, and also please share the summary of what you have learned from today's lecture in the comment box. Thank you. Allah Hafiz.